Limits, L'Hopital's. In the previous video we had a look at finding the limit of simple functions. What if we have a more complicated function? A function such as, what if we wanted to find the limit of x, x tends to 0, sine x over x? How would we work out this limit? As we have no factors in sine x and x, so we can't cancel, as x tends to 0, sine x tends to 0, and x tends to 0. So provisionally it is 0 over 0. But we can't divide by 0. This isn't an answer. So we have a rule called L'Hopital's rule, which states that the limit as x tends to a, where a is any real constant, of the quotient of two functions, f and g of x, if this is equal to 0 over 0, or infinity over infinity, where this could be plus or minus, then the limit as x tends to a, f of x over g of x is equal to the limit as x tends to a of f prime x over g prime x. So what we're saying here is that if we differentiate the top and differentiate the bottom, then that will give us the same limit. So let's have a look at how this can be utilised. So let's take our example of sine x over x. This is equal to 0 over 0, therefore L'Hopital's. So if we differentiate the top, so the derivative of sine x with respect to x is equal to cos x, and what x with respect to x is 1. We can clearly see that that is the limit as x tends to 0 of cos x, and as x gets closer and closer to 0, cos x gets closer and closer to 1. So there we've shown that the limit as x tends to 0 of sine x over x is equal to 1. What about if we have a look at a slightly different example? This time, rather than use trigonometry, we're going to have an algebraic expression. So we're going to have the limit as x tends to infinity this time of, sorry, that should be of t tends to infinity, 2t squared plus 2t plus 1 all over 4t squared, take 1. So we can clearly see here that as t squared plus 2t plus 1 tends to infinity, so as t tends to infinity, the whole thing will tend to infinity, and the same on the bottom. That is our infinity over infinity. And going back up to L'Hopital's rule here, we've got this case, so that means we can use L'Hopital's. So from here we differentiate the top and differentiate the bottom with respect to t. So it gives us 2t plus 2 over 8t. Do that again, 8t. Now if we let t tend to infinity, that will again give us infinity over infinity. So we're going to use L'Hopital's. The limit as t tends to infinity of 2 over 8. So 2t plus 2 differentiates to 2, and 8t differentiates to 8. Now 2 over 8 is equal to a quarter, which is a constant, so has no value of t in it, so we can say that the limit is just 2/8 quarter. And that is our limit. So we can have any variable here, it doesn't matter whether it's t or x. Head back up to where we wrote it down. It could be t, x, and it could be tending to any constant a here. So a is any real number, including 0, infinity, whatever. And it's when you can't find the limit, basically. I hope this has been useful. Thank you for watching.